A light sensor generates an output signal indicating the intensity of light by measuring the radiant energy that exists in a very narrow range of frequencies, basically called light, and which ranges in frequency from infrared to visible up to ultraviolet light spectrum. The light sensor is a passive device that converts this light energy, whether visible or in the infrared parts of the spectrum, into an electrical signal output. Light sensors are more commonly known as photoelectric devices or photosensors because of the convert light energy, photons, into electricity, electrons. Photoelectric devices can be grouped into two main categories: those which generate electricity when illuminated, such as photovoltaics or photoemissions etc., and those which change their electrical properties in some way, such as photoresistors or photoconductors. This leads to the following classification of devices. Photoemissive cells. These are photodevices which release free electrons from a light-sensitive material such as cesium when struck by a photon of sufficient energy. The amount of energy the photons have depends on the frequency of the light, and the higher the frequency, the more energy the photons have, converting light energy into electrical energy. Photoconductive cells. These photodevices vary their electrical resistance when subjected to light. Photoconductivity results from light hitting a semiconductor material which controls the current flow through it. Thus, more light increases the current for a given applied voltage. The most common photoconductive material is cadmium sulfide, used in LDR photocells. Photovoltaic cells. These photodevices generate an IMF in proportion to the radiant light energy received and is similar in effect to photoconductivity. Light energy falls onto two semiconductor materials sandwiched together, creating a voltage of approximately half a volt. The most common photovoltaic material is selenium, used in solar cells. Photojunction devices. These photodevices are mainly true semiconductor devices such as the photodiode or phototransistor, which use light to control the flow of electrons and holes across their p-n junction. Photojunction devices are specifically designed for detector application and light penetration, with their spectral response tuned to the wavelength of incident light. The photoconductive cell. A photoconductive light sensor does not produce electricity but simply changes its physical properties when subjected to light energy. The most common type of photoconductive device is the photoresistor, which changes its electrical resistance in response to changes in the light intensity. Photoresistors are semiconductor devices that use light energy to control the flow of electrons, and hence the current flowing through them. The commonly used photoconductive cell is called the light-dependent resistor, or LDR. The light-dependent resistor. A light-dependent resistor. Typical LDR. As its name implies, the light-dependent resistor, LDR, is made from a piece of exposed semiconductor material such as cadmium sulfide that changes its electrical resistance from several thousand ohms in the dark to only a few hundred ohms when light falls upon it, by creating whole electron pairs in the material. The net effect is an improvement in its conductivity with a decrease in resistance for an increase in illumination. Also, photoresistive cells have a long response time, requiring many seconds to respond to a change in the light intensity. Materials used as the semiconductor substrate include lead sulfide, PBS, lead selenide, PBSA, indium antimonide, InAsP, which detect light in the infrared range, with the most commonly used of all photoresistive light sensors being cadmium sulfide, CDS. Cadmium sulfide is used in the manufacture of photoconductive cells because its spectral response curve closely matches that of the human eye and can even be controlled using a simple torch as a light source. Typically then, it has a peak sensitivity wavelength, lambda p, of about 560 nanometers to 600 nanometers in the visible spectral range. Photojunction devices. Photojunction devices are basically p-n junction light sensors or detectors made from silicon semiconductor p-n junctions which are sensitive to light and which can detect both visible light and infrared light levels. Photojunction devices are specifically made for sensing light, and this class of photoelectric light sensors includes the photodiode and the phototransistor. The photodiode. 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 The construction of the photodiode light sensor is similar to that of a conventional p-n junction diode, except that the diode's outer casing is either transparent or has a clear lens to focus the light onto the p-n junction for increased sensitivity. The junction will respond to light, particularly longer wavelengths such as red and infrared, rather than visible light. This characteristic can be a problem for diodes with transparent or glass feed bodies such as the 1N4148 signal diode. LEDs can also be used as photodiodes as they can both emit and detect light from their junction. All p-n junctions are light sensitive and can be used in a photoconductive unbiased voltage mode, with the p-n junction of the photodiode always reverse biased so that only the diode's leakage or dark current can flow. The current voltage characteristic, IV curves, of a photodiode with no light on its junction, dark mode, is very similar to a normal signal or rectifying diode. When the photodiode is forward biased, there is an exponential increase in the current, the same as for a normal diode. When a reverse bias is applied, a small reverse saturation current appears which causes an increase of the depletion region, which is the sensitive part of the junction. Photodiodes can also be connected in a current mode using a fixed bias voltage across the junction. The current mode is very linear over a wide range. So this is all about light sensor and the working of the light sensors. For more videos, please subscribe to my YouTube channel. It's a humble request to you.